So let us now substitute the limits. My limits are infinity and r. So x is the variable where the limits are substituted. So the potential difference says that in an electric field, the work done in bringing a positive charge or a charge from one point to the other point. This plus q produces this electric field, and I need to bring another 1 coulomb charge from infinity to a point P. Hello everyone, welcome to session 1 of chapter 2 Electrostatic Potential and Capacitance. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the previous chapter, we have learnt about what is an electric charge, what is an electric field, the properties of electric charges, the properties of fields, and the concept related to electric fields. In this chapter, we are going to discuss about the electrostatic potential and capacitance and the topics related to these concepts. So let us begin with electrostatic potential. It is very important to know about the meaning first, then it helps us to understand the concepts related to that. So first, let us understand electrostatic potential. So electrostatic potential is denoted by a letter V. We know electric field is denoted by E. And similarly, electrostatic potential is denoted by V. So it is defined as electrostatic potential at any point in an electric field is the amount of work done in bringing a unit positive charge from infinity to a point in an electric field, which means we have a charge at infinite distance. We have to bring that into an electric field. So what is the amount of work done to bring the unit positive charge or a charge from infinite distance to one particular point in an electric field? So that amount of work done is nothing but electrostatic potential, and that is denoted by V. So it can be represented as V is equal to W by Q, that is amount of work done to bring a unit positive charge from one distance, that is from infinity to a point in an electric field. Or this can also be written as V is equal to U divided by Q, where U is nothing but the amount of work done is nothing but the potential energy. So V is nothing but electrostatic potential, W is work done, and Q is the charge. So what is the SI unit of this electrostatic potential? We know the SI unit of work done, that is joule, and the SI unit of charge is coulomb. So the SI unit is joule per coulomb, or we can say it as volt. I hope it is clear to everybody, electrostatic potential. Now let us understand what is electrostatic potential difference. What do you mean by potential difference? We know if we are bringing a charge from infinity to one point and the other point in an electric field, from one point to another point, the work done is different. So we can say the potential is different at 2 points. So the potential difference says that in an electric field, the work done in bringing a positive charge or a charge from one point to the other point. What is the amount of work done in bringing a charge from one point to another point? The difference, if we calculate, we will get potential difference, or we can say it as electrostatic potential difference. Say for example, we have system of charges Q1, Q2, Q3, Q4, Q5 and Q6 at different points. Now I need to calculate what is the difference between the potential at point A and point B, which means the potential at this point is different and at this point is different. So now to find the potential difference, we can say delta V is equal to VA, the potential at A minus the potential at B. So if you come to know what is the amount of potential or amount of work done at point A and amount of work done at point B, we can easily find the potentials at 2 points. And the potential difference, that is delta V, can be calculated at 2 points as VA minus VB. Here VA is nothing but potential at A and VB is nothing but the potential at B. So that is equal to W by Q, which means the amount of work done in bringing charge from one point to another point. So W is the work done and Q is the charge. Now we got to know what is electrostatic potential and how to find the potential difference. Now let us understand, is electrostatic potential a scalar quantity or a vector quantity? So it is just a work done in bringing a charge from one point to another point. So it is a scalar quantity. So let us define 1 volt, or let us understand electrostatic potential is a scalar quantity. So how to define 1 volt? We know the expression V is equal to W by Q. If the work is 1 joule, if the work done in bringing a charge is 1 joule and the charge is 1 coulomb, then V is equal to 1 divided by 1, that is V is equal to 1 volt. So we can define 1 volt as if 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point in an electric field, then the potential, that is V, will be equal to 1 volt. If the work done is said to be 1 joule and to bring a charge of 1 coulomb from infinity to a point in an electric field, then potential value will be equal to 1 volt. So it has no particular direction to move on. So it is a scalar quantity. It has got just magnitude and hence it is a scalar quantity. So now, after knowing about all these basic concepts, let us derive an expression for electric potential due to a point charge. We know what is a point charge. So I have a point charge. I have taken a point charge in an electric field. So let us consider point charge and find electrostatic potential due to it. See here, this is an electric field. Understand the diagram clearly. So in an electric field, I have considered a point P where I have to find the potential. Let O be a point where I have placed a charge plus Q, which is at a distance R from P, and A and B are the two different points, or they are separated by a small distance dx. Let A be any distance, that is x, from this point O. So this plus Q produces this electric field and I need to bring another 1 coulomb charge from infinity to a point P, and I have to find out what is the potential at this point. So to calculate the potential at this point, I am considering two different points and we are just calculating what is this amount of work done to bring the charge from infinity to this point. Then after integrating, we can find what is the total work done in bringing a charge from infinity to a point P. So this is our diagrammatic representation of the assumption. Now the magnitude of electrostatic force on a unit positive charge at A. See, I am bringing a unit positive charge, that is plus 1 coulomb from infinity to A. So now here I have plus Q charge, here I have plus 1 coulomb, which means I have two charges. When there is a two charges and they are separated by a distance, then we say there exists a force between these two charges, and that can be written with the help of Coulomb's law, that is F is equal to 1 by 4 pi epsilon naught Q into 1 divided by x square. Why? Because we know Coulomb's law says that F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. What is Q1 and Q2? Q1 and Q2 are the charges and R square is nothing but the distance of separation, or the square of distance of separation between those two. Now I have Q1 according to this condition is plus Q, and Q2 according to my consideration it is plus 1 coulomb. So here Q into 1, and the distance of separation between these two charges is x. That's why Q into 1 divided by x square, and this is my first equation. So the small amount of work is done in moving a unit positive charge from A to B. You can see here dx is a small distance moved by the charge. The small amount of work is done to bring a charge from A to B, and that can be represented as dW, which means a little amount of work is done. So we know work done is equal to F into dx cos theta, where dx is a displacement, F is the force. So in this is the direction of electric field, and that is the electrostatic force, and the force and the displacement of the particle are just opposite to each other, and therefore theta is equal to 180 degree. If cos 180 is equal to minus 1, we'll get the equation dW is equal to minus F into dx, because we have F dx cos theta. If cos 180, if I substitute, then this will give me a value minus 1. So we get dW is equal to minus into F dx. Or in general, we can say force and the displacement are just opposite to each other, is the symbolic representation of negative sign here. So dW is equal to, what is F? Let us substitute in the place of F 1 by 4 pi epsilon naught into Q divided by x square dx. That is from the equation 1. So we get dW equals minus 1 by 4 pi epsilon naught into Q by x square into dx. So now this is a small work done. What is the total work done in moving a unit positive charge from infinity to this point? At point P, we have to find out the potential. So for that, we need to integrate. See, these are the small distances. So if we integrate from the point that is infinity, the limits are infinity and this distance with respect to the charge plus Q, that is from infinity to R. So if you integrate small work done, we will get the total work done. So total work done can be calculated by integrating with the limits infinity to the point P, that is at a distance R from plus Q. I am integrating this equation, that is integral of dW. If you integrate small work done, we will get work done, that is total work done, which is represented by capital W, which is equal to minus integral of infinity to R. These are the points, which means I am bringing the charge from infinity to this distance 1 by 4 pi epsilon naught Q divided by x square into dx. Now look at this expression. I can take Q divided by 4 pi epsilon naught outside with the negative sign and I remain with integral of infinity to R into 1 by x square dx. Now we have to integrate this part. So we have 1 divided by x square dx. I can write this as integral of x power minus 2 into dx from the limits infinity to R. Now this is of the form integral of x power n dx, and that is equal to x to the power n plus 1 divided by n plus 1. So considering this example, in the place of n I have minus 2. So I get integral of minus x to the power of minus 2 into dx, which is equal to x to the power of minus 2 plus 1 divided by minus 2 plus 1, which is equal to x to the power minus 1 divided by minus 1. So I can write this as minus of 1 divided by x. So I have taken after integration W is equal to minus Q divided by 4 pi epsilon naught into minus 1 by x. So minus 1 by x, for that I have up to apply limits. So this is our answer we got from integration and I have substituted here. So let us now substitute the limits. My limits are infinity and R. So x is the variable where the limits are substituted. So to substitute the limits, we know the rule, upper limit minus lower limit. So now minus into minus becomes plus and hence I have no negative sign here. So W is equal to Q divided by 4 pi epsilon naught into, in the place of x, first I am substituting upper limit. So 1 divided by R minus 1 divided by infinity. So 1 by infinity value is how much? It is 0. And I remain with W is equal to Q divided by 4 pi epsilon naught into 1 by R. And this can be written as W is equal to Q divided by 4 pi epsilon naught into R. So from this definition, we can say the work done is equal to electrostatic potential. We know what is the electrostatic potential. It is the amount of work done in bringing a charge from infinity to a point in an electric field. So the definition, this work done is equal to electrostatic potential V at the point due to a charge plus Q. So therefore, we can write W is equal to V into 1 by 4 pi epsilon naught into Q divided by R. So this is the expression for electrostatic potential. So now we can say, from this we can say, how does the potential vary with the distance? So we can say V is inversely proportional to R. You may also get a question, how does the electric field vary with respect to distance? We know the equation for electric field, that is 1 divided by 4 pi epsilon naught Q divided by R square. So this is electric field. So in this case, E is inversely proportional to the square of the distance, and electrostatic potential, the electrostatic potential is inversely proportional to 1 divided by R. So this is the expression for electrostatic potential. So in today's session, we have learnt what is electrostatic potential, what is the potential difference, and what is the expression for electrostatic potential due to a point charge. So in the next session, let us learn more concepts regarding electrostatic potential and capacitance. Until then, keep learning all of you. See you all in the next session. Thank you.